Hi, welcome to this video lecture on the subject electronic circuits. So in this lecture we are going to discuss about bias compensation using diode and thermistor. So first of all, let's see the need for bias compensation. So in transistors, so operating point is affected by many factors like temperature, changes in current gain, like that. So if the operating point is affected, the stability is not achieved. So the transistor cannot be used as an amplifier. So to set the operating point of the transistors, we need to bias the transistor by using proper biasing circuits. So the to achieve the stability, we can use the bias compensation circuits to fix the operating point stable. So it uses temperature sensitive devices such as diodes, transistors and temperatures to compensate the changes in current and voltage so that we can maintain the operating point or Q point in stable value. And let's see the thermistor compensation in this circuit where we have taken the common emitter amplifier circuit. Here the thermistor is used, it is given as the RT in parallel with resistance R2. And what is the meaning of thermistor is, it is then negative temperature coefficient device thermistor. So here the resistance decreases with respect to the temperature. So when we connect or when we use the thermistor in this circuit, so whenever the changes occurs due to temperature, the resistance decreases so that the voltage drop across the R2 also decreases. So when the voltage drop decreases, it will decrease the value of base emitter voltage so that the base current also decreases. So when base current decreases, what will happen? The collector current is also decreases. So it will offset the changes in collector current. So whenever the changes occur in collector current, so it will be compensated by using the thermistors. And when temperature increases, the resistance of the thermistor exponentially decreases, as we have already discussed. So this RT voltage drop also decreases. And next is the transistor compensation. So transistor compensation, we use positive temperature coefficient device. So here we connect the transistor parallel with resistance R1. It is mentioned as RS by a circled resistance. So in which it is compensated by the changes in VBE. Here when temperature increases, the resistance of the transistor also increases. So here the R1 value increases, drop across R1 increases. So the base emitter voltage uh, decreased because of the voltage drop across R1. So that correspondingly the base current also decreases. So what will happen in the collector current? It is proportional to base current, IC equal to beta into IB, so that collector current decreases. So it will offset the changes in the collector current. So let's see the activity. Review the biasing management used for common emitter amplifier. And next we can see is diode compensation circuit. So this diode compensation is used for offset the variations due to IC naught, which is saturation current, and also variation in VBE. So these two parameters changes with temperature. So when temperature changes, the collector current, so and also VBE saturation, reverse saturation current, and VBE also changes. So these changes affect the collector current. So by using the diode in series with R2, we can offset the changes in collector current because the diode voltage drop also changes due to temperature. So this voltage drop will reduce the VBE. So by this we can decrease the collector current, which is compensation for the changes in operating point. So here the diode is connected in series with R2. So the diode is generally biased in forward bias condition in this circuit. So the calculation for emitter current is given by VE divided by RE, where it is written as VB minus VBE divided by RE. So such that here voltage drop across R2 is added with VD, so that the VB voltages decreases. Then the collector current is obtained like this: VR2 plus VD minus VBE divided by RB. So, so the IC is decreased by this diode compensation. So let's take the assessment. What are the primary reasons for needing bias compensation in transistor circuit? So bias compensation is used for achieving the stability of transistor circuit, and key parameters are VBE, IC0 and beta. So thank you for listening this lecture.